Yes, hello. Hello, everyone. If you're here, if you joined us in this room right now, that means that you are ready to upgrade your applications to Java 17. And then also think about preparing for Java 21. I have like many questions about the semantic versioning there because what happened to 18, 19, 20? Did they ever happen? But anyway, this is not a session for me to ask you questions. Hopefully, other people in the room will have questions later because we still have an umbrella to give away. And if I've learned something from my 1 week in Vilnius, it's that the weather is very unpredictable. It's not. But you might just need an umbrella today or tomorrow. So, you have a chance to win one. So, Johan Janssen is working as a software architect at ASML. He's been working for various demanding companies where rapidly delivering high quality software was very important. I feel like it's an important thing. You regularly write articles for InfoQ and for Java magazines, I suspect on Java topics. And you received a Java 1 Rockstar and Oracle Code 1 Star awards. So you're an accomplished fellow too. So without further ado, please take it away.
Thank you. So yes, indeed, this is about upgrading to the new version of Java. So we won't talk about cool new features of Java. We won't talk about AI. We talk about the boring stuff to get you on the new version of Java so that you can finally use all those cool new things. But first of all, I'm interested. Which version of Java are you using? Who's already using 21? Bit of a trick question, of course, because it's not released yet. But you can actually already download an early access release and try around with it. So I tried it for some examples that I have. Who's still using Java 17? Okay, Java 11, 8. It's more or less what most people do. I heard what's with these numbers. We'll come back to the other numbers in a few slides. So that's what we see mostly. That still a lot of projects are lagging a bit behind. So let's see how we can help with that. And then my clicker refused to do something. Then we do it like my entire. Okay. So if you have any questions, you can ask them here, or you can later ping me on Twitter or LinkedIn. And this entire presentation is based on my GitHub repository, which you can find if you simply go to GitHub with my name and then click on Java upgrades. So a lot of examples are in there, like errors that you get when you upgrade from one Java version to the other, and how to fix those errors. So a lot of information is contained inside that repository, and it's basically the basis for this talk as well. Yeah, so I've been upgrading Java applications. Oh, I see it's not full screen. I've been upgrading Java applications for a really long time, from Java 8 to 11 to 17, also other upgrades that I did. So I have quite some experience doing this for various teams. And basically, I want to talk a bit about that and help you also make your migrations a bit easier. Questions I already said, simply ask them. But first, why would you actually upgrade Java? There are some good reasons for that. You get new performance benefits, security improvements. But I think for us developers, the most interesting part is being able to use those cool new features like records, pattern matching, Project Loom, which is coming up in Java 21. We want to use those cool new things, of course. If you look at performance statistics, here it shows that for various versions of Java, what the memory usage is. So you see that with Java 16 it was most usage, and with Java 18 it was the less amount of usage. But of course, with these kind of statistics, never trust statistics you didn't falsify yourself. So test it out with your application if you truly want to know what the difference is. It depends really on your kind of application. Why wouldn't you upgrade? Yeah, there actually it can be a bit of work. We will see that it's probably not as much work as most people expect, but still it is some work. And what I also notice is that a lot of people are afraid of the Java module system, Jigsaw, which was introduced in Java 9. A lot of people think that they need to use it. Actually, you don't need to use it. You can just build a normal application without all the module stuff. And that's what most of the world is doing. And if you're interested, you could opt to choose the module system. Like records or other new features in Java, they're optional to use. One other disadvantage can be the fact that you build an application which is deployed at a customer site, and your customer still has some old version of Java running. And there's actually a nice way to work around that with the multi-release jar feature, which is a bit older feature, but I think it's interesting because a lot of people are unaware of it. So how does it work? We can basically create two versions of like a class, in this case the student class. So one is in the plain Java package directory and one is in the Java 17 directory. So to simply look at some code to make it clearer, this is the normal student. So this is a student class, probably familiar to everyone, just with some simple stuff in it. It has an isBlank name, which has some logic in it to check if the name is blank. And then we have a second student class, which is here. And actually, this is not a class, but it's a record, a new feature of Java. And the isBlank name, nowadays we can use the newly introduced isBlank method on a string. So here we have some newer stuff. And then we need to configure some things in our pom.xml. We have to say, okay, if I compile it, my normal classes should be compiled with Java 8. But I also have some classes which should be compiled with Java 17. And they are located in the directory that I just showed you, the source main Java 17 directory. And then actually you can build one jar file on Java 17. I already built the jar file. And then I can run that version of my application on multiple versions of Java. So I use Docker to quickly do that. So if we look at the output, okay, I have apparently the old run also still in here. Let's make it a bit clearer. So we see for Java 8, it is using the Java class implementation, because I mean Java 8 doesn't support records yet. For Java 11, still Java class implementation, as you can see here. On Java 17, we see it uses the record feature, and the same for 21. So 21 you can already test the early access. It also uses the record feature. So this way you can create one application which runs on multiple versions of Java, making use of new features already. So you could, for instance, if there are methods in Java 21 that perform better, or Java 17 that perform better, you can already use them so that customers who are on a newer version of Java already have those performance benefits. And customers that use an old version of Java, yeah, they should simply upgrade. They have the slow version. Yeah, make sure the API is the same. So the student class and record should have the same methods basically, because else you can get all kinds of runtime errors, but you can automatically validate that nowadays. If you use Docker, like I showed before, it's really easy to test out some small things. I, for instance, had an issue. I upgraded an application which was from another team, got a really weird error, didn't understand it, worked on it for like a day, couldn't figure it out. Then I thought maybe it's something with my settings on my machine. My machine was already a bit older, already used for all kinds of stuff. So I wanted to run it in a fresh environment. So I ran it in a Docker image or a Docker container, and then the error disappeared. And after that, I found out it was actually some really weird behavior where the project, some code didn't work on my Windows machine and all my colleagues were using Mac machines. So it was just an issue on my machine. I didn't need to work for the rest on the project, so I could just commit it and I was done. So yeah, why do I show these kind of things? From my experience, there's a lot of uncertainty while upgrading. If you ask developers, oh, okay, how long does it take to upgrade your project to a new version of Java? I've had colleagues in the past who said upgrading from Java 8 to Java 11 would take 3 months with a couple of people. And then you can probably guess what the reaction of management was. They were like, okay, we postpone it, because they don't see the benefits, and investing 3 months of work with a couple of persons is rather expensive. And I think that's one of the reasons that we still stay on old versions of Java. Well, I think that most of the issues that we see are actually recurring in all the applications. There's only a small set of issues that is specific for your project. So I want to help with that. I use Maven as an example, but basically you can use Gradle or any build tool that you provide. It's just that I don't want to duplicate all my examples for different build tools. And so let's go on in this journey. And here we come with the Java releases. So in the past, we had a Java version every, what was it, 5 years or something. Later, they started to do more releases. And actually, they release nowadays every 6 months. And a long-term support version was released every 3 years. And that's now increased to every 2 years. So to come back to your question, what happened to all those versions in between? So Java 8, Java 11, Java 17, and Java 21 are all long-term support releases. All the versions in between don't have a long-term support. They are suitable for production. That's what every vendor says. But after 6 months, the support basically stops. I'm wondering, is anyone using a non-LTS version in production? That's also what I basically see. So non-LTS is used for some testing, some demos. But if you look at production applications, almost all of them run on LTS versions because they have support for like 3 years. You get minor updates every couple of months for multiple years. Well, for the short-term support versions, you only get updates for like 6 months. So which one to choose? Yeah, I mean, I prefer to stay on LTS. They have a bit longer support. And that every 2 years nowadays is for most companies quickly enough to do a full upgrade of their entire environments. If you go and upgrade your application, then what do we have to do? In general, we have an application with some application code, and most projects have some dependencies. I know some projects who wrote everything themselves. That's also possible, but in general, you use some dependencies, some open source projects, and it all runs on Java. So when something is removed from Java, you either need to update your application code or your dependencies, or both. And then, as I say, a lazy developer is a good developer. It sometimes pays off to wait a little bit before those dependencies are upgraded for you. If you use the latest versions of those dependencies, then often they are already run on the latest version of Java. Or already before a new Java release or shortly after a Java release, most of the popular dependencies make sure that they upgrade their dependencies so that they are compatible with that version of Java. If we talk about deleting stuff from Java, then we can talk about many things, but in the end, most of the times stuff is first deprecated. So they mark it for deletion for a couple of versions and then it's actually removed. So if you are ready, make sure that you fix the deprecated stuff in your application. Then by the time it's actually removed, you are already done. So this is an example of JXB. There are multiple examples for it. Then what can be actually removed from a Java environment? That's a lot. It's basically anything. So from security certificates to even complete applications like Java Mission Control. Java Mission Control is a profiling monitoring tool which was part of the JDK. It's no longer part of it. You can download it separately. If you want to do something with profiling, I can highly recommend it. It's a really awesome tool. On really low level, there are some websites that give all the details, like which methods have been removed and which methods have been added or deprecated. So this is like the Java Almanac website. There is a comparable website on Fuji which offers these details. It's probably not something to read through entirely unless you have trouble falling asleep at night. But sometimes when I had an issue and I was like, hey, why does this no longer work? And I looked at this one and found out that that method was actually removed in the newer version of Java. So it can be helpful as a reference. If you want to have other detailed information, I can recommend the OpenJDK website that basically gives the high-level changes. So for instance, records that have been added, stuff that's been deprecated, etc. And Oracle nowadays also offers release notes which are available. So this is mostly a bit higher level information. They also provide some information about certificates that have been removed. So if you're security aware, probably also a good point to have a look at. And there's also an Oracle JDK migration guide. And then if you do the upgrade process from Java, you probably want to have multiple versions of Java installed at once because you want to upgrade your application and still you need to fix bugs on the old version of your application. So there are some various ways to do that. I put Docker in here. Docker is relatively easy, but the feedback loop is a bit long because then you need to build it inside a Docker image, wait for the feedback, and then you can fix it again in your IDE. So probably you want to have your IDE also running on some new version of Java so you can make sure that you upgrade quickly. If you want to try out some stuff with Docker and you're really new with Docker, it's really easy. You create a file called Dockerfile, put stuff like this in it. So this basically puts everything in the directory, in your current directory inside the Docker image. And then with the Docker build -t Java upgrade, and the dot. So the dot, you don't need to forget it. It's not the end of the line, but it specifies the context, the current directory. It's the most difficult thing about using Docker. You forget the dot. With this, basically, your application runs in that specified version of Java. So you could use this, for instance, to check if your application is already compatible with the latest version of Java without having to upgrade Java on your host machine. If you roll out a new Java version, in general, you start on your local machine, you start to fix all those compile errors that you encounter, then you start with upgrading stuff in the build environment, and in the end, you deploy it on production, and maybe acceptance or testing environments. So with all the ingredients, it can be sometimes difficult to find like the needle in the haystack. If you upgrade from Java 8 to 21, and you encounter any errors, it's difficult to see what exactly caused those errors. So sometimes it might be good to do it step by step. Go, for instance, from Java 8 to 11, then to 17. To be completely honest, I'm a bit lazy. I mostly go at once, but if you really encounter any tricky stuff, might be good to take an extra step in between. Just see what works best for you. Then I think there's one important thing to check before you do these upgrades, and that's to check what frameworks and tools do you actually use, and do they support the latest version of Java. In the past, I worked, for instance, with Apache Spark. Apache Spark is lagging a bit further behind in supporting new versions of Java, so we have to wait until Spark is upgraded before we can do the Java upgrade in our application. If you use stuff like Spring, they're really quick. You can support it from the day the new version of Java is released, basically. So if one of those tools doesn't support it, probably best to wait a bit and not try to upgrade, because then you need to fix all the issues that you find in those dependencies. So for preparations, make sure that your environment is actually using the latest version of Java 17 with all the IDE customizations and everything, and the Maven compilers and stuff like that. Make sure that everything is using Java 17 or 21, wherever you want to upgrade to. And not something is still using Java 8 or something like that. So make sure you configure your Maven compiler, for example, to release 17. So everything runs on the correct version. And then the most important thing that I saw when upgrading applications is that you make sure that your dependencies are actually up to date. If your dependencies are up to date, then upgrading Java is often a breeze. It often works at once. I did quite a few upgrades from Java 11 to 17 for like, I think it was 5 or 6 projects from different teams. And apart from upgrading some dependencies, I only needed to change one line of code, which I will cover later. So if you already have up-to-date dependencies, it will be a breeze. So use tools like this, like Renovate, Dependabot. They create pull requests for you to automatically update your dependencies, or use some manual tools like the Maven or Gradle versions plugin to see what the latest versions are for the dependencies that you use. And then one thing to be careful with is that sometimes dependencies get a new name. For example, we had Java EE in the past. Nowadays it's Jakarta under the Eclipse Foundation. In the past, the artifact was called like this, and nowadays the artifact is called like this. So if you simply update to the latest version, you're still stuck here. Well, if you use the new name of the dependency, I think this one already got a new version. I have to look that one up, but this one still receives updates. And therefore, there is also a plugin available. So the old group IDs alerter checks all your dependencies to see if there is some new artifact available because the project changed the name or someone created a fork or something like that. So this can be automated in your build to check these kind of things. And then when we actually do the upgrade, I always recommend to do it step by step. Don't try to fix everything at once, like fixing your source code and your tests at once. Just try to compile everything at once in your source code, then start working on your tests that they compile and that they can actually run, because then you can actually show progress. Because again, it's often, I think the difficult thing about upgrading is convincing management and other people to invest time in this. And if you're already spending a couple of days on it and you're like, I'm 80% done, then you run the risk of them saying, okay, we postpone it for a while because you already spent a week on it. Well, if you can say, okay, my test or my source code compiles, my tests are running, I simply now need to deploy it on an environment to test it, then you can show actual progress. That helps better. It's better for your own motivation and for your team's motivation as well to do stuff step by step so that you can get concrete results. And then if you're lucky, you get a nice pizza or a nice running application. And then to quickly go over the changes that were made in the various versions of Java, because these are the major things that have been changed. One is that JavaVex has been removed, basically to create the front end. And it's actually removed from the JDK, and now you can add it as a dependency. But what a lot of people are not aware of is a lot of vendors nowadays create JDKs. Amazon creates one, Oracle creates one, you have the Adoptium project. A lot of vendors do it. And some vendors actually create JDKs with the basic stuff in it, which all the JDKs have, and they add some extras. So for example, Liberica offers a JDK which still contains the OpenJFX implementation. So if you use JavaFX, you could consider using that one. Another thing that was changed, which one of my colleagues encountered while using, I think it was Apache Poi or something like that, which deals with fonts. So in the past, Java had a few fonts in it, really small number, like 6 or 8 fonts. And if it couldn't find the fonts there, it will try to find the fonts in the operating system. In Java 11, they removed the fonts from Java, which isn't a problem because then it will simply look them up in the operating system. However, if you use an operating system like Alpine Linux, which is really small, it also doesn't contain any fonts. So then you get really weird issues because the font cannot be found. So the solution then is to install those fonts on your operating system directly. Like mentioned before, so Java Mission Control was been removed, so you can download it separately nowadays. So really awesome, so check it out. And then I think the biggest change in Java 11 was the removal of the Java EE modules and Corba. Corba probably doesn't impact you because it's really old, but Java EE I think impacts most projects. So what we need to do is we need to change all our dependencies to the new Jakarta dependencies and make sure that we use the right imports everywhere. And it goes for all of these. Most important columns are the first and the last one. So first, these were all included inside the JDK. Nowadays, you need to add them manually as dependencies. And for JUXB and JUXWS, you need 2 dependencies, one for the API and one for the implementation. So make sure that you have the correct dependencies in your application. I think that's most of the work when you go from Java 8 to Java 11. Then Java 15. Who's using Nashorn here? I always thought no one was using it. I only saw it at conferences until I upgraded some projects from my colleagues and got an exception that Nashorn couldn't be found. So apparently it's used in more projects than you think. If you encounter it, you can simply add it as a dependency. It's no longer part of Java anymore, but with a dependency, you fix the issue. And then in Java 16, they started to work on the JDK internals. So what did they mean with that? In the JDK, you have some really low-level code for reflection and things like that. In the past, Java couldn't hide them away. So we, as normal developers, could use all those internal features of the JDK. But they actually didn't want us to use them. After a while, we got the module system. So with the module system, they could hide away stuff. But they opted to still make it available for us. Because else basically every application in the world would break. Now we are a couple of years further and they're trying to restrict access to those internals more and more. So in Java 16 we see the first step there. They try to shield us away from those. So what's the solution then? Again, update your dependencies. Tools like for instance Lombok and also mocking frameworks for testing, they use those internals of the JDK. If you upgrade to new versions of those dependencies, they make use of the higher level APIs inside the JDK, which are still open and available to everyone. However, if you cannot upgrade your dependencies or you have a lot of code that uses internals, there is a workaround. For example, if you use Maven compiler plugin, you can specify the compiler arguments like this, which basically again opens up those internals for your application. It's ugly, of course, because I mean there is a reason they try to shield it away. It's like breaking into a house. But if really necessary, you can do this. Of course, I recommend first updating all your dependencies and see if you can prevent this. There is one even more ugly workaround, and that's starting Java with the Java process with the ---- illegal access modifier, and then everything is open. So that's also quite ugly, basically. You see when this happens, when you see an error like this. So for example, cannot access class because blah blah, JDK compiler does not export some stuff to a named module. It's an unnamed module because I don't use modules in my application. If you use a module, it would show a nice name here. So if you encounter errors like this, you probably need to upgrade some of your dependencies or use those nasty hacks to again open up the internals. Then in Java 17, We see that the experimental AOT and JIT compiler stuff has been removed. That's more part of GraalVM nowadays, which is funny because they remove it from the JDK, move it to GraalVM, and now GraalVM is coming back to OpenJDK, so looks like they're shifting some stuff around. And we again see that there is some strongly encapsulated JDK internals. So that's the most interesting change, I think, in Java 17. So what does that mean? It means that this command no longer works. So they introduced a workaround, and in the next version, the workaround is removed. So really make sure that you fix these things, because they make it harder and harder for you to use those internals. For a reason, of course, because they are hard to maintain properly for backwards compatibility. So again, make sure you upgrade your dependencies. They also made a lot of new higher level APIs that you can nowadays use. I had it for one project. We used some internal reflection stuff in our tests, and I could easily rewrite it. It was just one issue that I needed to fix, and that was it. So in most projects, you probably won't encounter many issues in your own code. Most of the issues are in dependencies like Lombok and mocking frameworks. And the last resort, you can still use that -- add opens, for example, in your unit tests to again open up everything. But yeah, I wouldn't be surprised if there will be some version of Java in the future where they block this as well. Then to give some examples, so if you upgrade or test early on new versions of Java, you might encounter some issues, like for example in Mockito, when we have an enum with a method inside it, and we try to mock it. Yeah, we got some exceptions when I tried that, but that was, in the project from Mockito, I raised an issue, and they fixed this already long before the release of the new version of Java. So you see that all these projects, they try to make sure that they fix stuff before you actually start using it. Same was for Kotlin. In the past, it didn't support the JVM 17, and it actually gave a really good error. It says what's actually supported. And I could use an older version, and it still worked. And I think by now, they also fixed this one. If you look at the newer versions of Java, so after Java 17, with Java 18, nothing really has been removed, but they say, okay, you should stop using the finalize method and use cleaners and try with resources to make sure that your resources like database connections are properly cleaned up. If you do it in plain code, it's quite hard, a lot of corner cases. With cleaners and try with resources, you can do that a lot nicer. You aren't forced to do it yet. The old way is still available, but it's deprecated, so you should start working on this. For Java 19 and 20, there are no official major removals or deprecations, so some methods might have been removed, but no big, large features, so that's easy for us. And for Java 21, it's being released in September this year, so still a couple of months to go. Content is still getting more and more clearer, but it looks like most of the content contains cool and new features like Project Loom, and not really any deprecations or removals. But it's still not finalized, so they might add something. Which also means that probably the upgrade to 21 will be relatively easy if you're already on 17. So you might, if you go to 21, you might get some errors like this, where you see, okay, Java 21.65 is not supported. If you go from some other versions, you might also see unsupported class file major version 61. Does anyone know what this class file major version thing is? I never heard about it when I started upgrading. I was like, what is this? I mean, I'm not upgrading to Java 61, right? I wish we go that fast, but it goes a bit slower. And actually, they have apparently a version for the class file format, which is not directly coupled to the Java version. So the class file major version 61 is the class file format for Java 17. So yeah, it's a bit confusing, but apparently they had some more class file upgrades in between those Java versions or somewhat. But if you ever see these kinds of errors, like 65 is basically for Java 21. And it basically means, okay, whatever you're using here doesn't support Java 17 or 21 yet. So again, you probably need to update your dependencies. Like for instance, Jacoco gave that error as well when I did some upgrades. So I needed to upgrade to my Jacoco dependencies. Same for all kinds of plugins in Maven. So you encounter this in various places when you do upgrades of your project. If you, of course, upgrade your dependencies and plugins up front, you don't see this. But if you're lazy and you don't update your dependencies and first try to update Java, then you will see some of these issues in your projects. So this I already explained. So it's a bit weird, the versions, but once you know that it's tied to the Java version, it's quite okay. So finally, when we have made all those changes, we're finally there on the mountain. We can finally make use of those cool new features like records and pattern matching and everything. And then I actually found out that you can even simplify this. There are tools like Open Rewrite, which is getting more and more traction. And Open Rewrite, yeah, to say it a bit disrespectful, they have like recipes to change your application. It's way more advanced. So they can, for instance, upgrade your application from Java 8 to Java 17 or to the newer version of JUnit. And it not only upgrades your dependencies and stuff, it also improves your code. So it will make use of new language constructs for you. For instance, did it from JUnit 4 to JUnit 5, and it uses the improvements of JUnit 5 already in your code base. And you basically just run it locally. It's available as like a Maven plugin. You run it locally, it makes some changes. You can decide for yourself which changes you want to accept and want to push to your version control system. And of course, yeah, test your application if indeed everything works, because there might be some corner cases. But this might really save you a lot of time. I did most of my migrations before I was aware of this tool. A lot of manual stuff. Of course, you can use your IDE and do a lot of find and replace stuff, but it's still annoying work. With tools like this, the migrations will become even easier. Yeah, so to come back to a summary, so if I look at upgrading, so if you go from 8 to 11, that's relatively a bit more work because you need to change from Java E to Jakarta. From 11 to 17 is a bit easier. When I did the upgrades, I was lazy. I just did the upgrade on existing project without upgrading dependencies and stuff. And the only things I needed to update were Lombok and mocking frameworks, and as I said, one line of code. So that's relatively easy. So I did, I think, one project per 2 days or something like that. Of course, I did it more often, so I have some experience in it. But even the project where they estimated that it would take a quarter with a couple of people, I did that project in, I think it was about a week. And I was mainly waiting on builds to finish because, yeah, you need to test if everything still compiles and the tests run. So if I look at it, if you do an upgrade of an application, most of the time it's a matter of days, maybe weeks if you use maybe some weird frameworks or a lot of different frameworks, but it's definitely not months of work. Then you're really doing something wrong. And actually, most of the time that you spend is in those builds to finish. So you could do some actual work in between, or you could drink a lot of coffee, whatever you prefer. And I think it's important that I think we should, as developers, we can continue blaming management for not allowing us to upgrade our applications. But in the end, if you look at it, who has most benefit of the upgrade? It's probably us. We want to use those cool new features. So in the past, I often did like when my week was almost over, I finished my hours and was like, yeah, let's spend a few extra hours on Friday to try if I can upgrade the project to the new version of Java. So I worked on it for a couple of hours. Then I got a better indication, like, okay, I have it compiling now, I need to fix some tests. So probably if I have like 1 or 2, maybe 3 days extra, then I can probably fix everything. So then I went to management and said, okay, can I have 2 or 3 days to wrap this up? And then they're often inclined like, yeah, okay, if it's 2 or 3 days for one person, that's fine. It's a lot better than saying I need a quarter with 3 persons. So take your own responsibility in this as well. Try simply to do this upgrade, also to show to management like, hey, it's not that weird or magical. It's just work, couple of days, maybe even a couple of hours if you're lucky, and it's working. So really make sure that you start with upgrading to the new versions already. And I think going from 17 to 21 will be really easy because I haven't seen any major removals there. So of course you can improve your code by not using the finalizers anymore, but plain upgrading should be really a breeze. And I hope that Open Rewrite might also support Java 21 in the future if there are any quirks there, but let's see. So that's it. Any questions? I think we have some time left.
Anyone in the room? We have a question on Slido. I saw that.
Ah, it's here.
Oh, yeah. Do you want to read it out?
Yeah, I will read it out. Does old group IDs alerter check for other changes, like license changes as well? As far as I know, I looked into the code base of old group IDs alerter. What it basically is, it's, I think it was a JSON format. It's like a really long list with old artifact names and new artifact names. So it simply goes through your dependencies and checks if you have one of the old ones, and then it recommends one of the new ones. I don't think it checks for things like licenses. So that's something you need to check yourself if you're concerned about that.
Any other questions? You can win an umbrella. That was my question, and I'm not winning the umbrella.
Did I answer your question about the versions?
You did. Thank you. You did in the very beginning. Thank you very much. I was very confused about those, and now I feel enlightened.
Basically, most of the world doesn't use those other numbers.
Yeah, it's interesting. If there's no more questions, we have a longer lunch break, which is also a good thing, I think. Later in this room, we'll have 2 panel discussions about AI and humans in technology. Turns out we're all humans in technology. Did you know? I didn't. So see you back after lunch. Thank you so much, and thank you for your talk. We have a little gift for you.